Hello students, I am sorry that I'm not here today to teach you in person, and hopefully this video will be quick and painless. I just want you to follow along with all the sections. I've divided it into a mild, medium, and spicy kind of situation, and then you're gonna try one on your own, and hopefully you will figure out that as we do these problems, they're actually all mild. The goal is to get from these crazy looking problems where there's stuff everywhere into the more simple stuff. So I'm just gonna walk you through the first couple problems, so take notes as best as you can, but remember, the goal here is to get x alone. So what I want you to be thinking about is, take a look at your equation. We'll start with the first one, right? And you're going to be thinking, I need to get this x all by itself. So the questions should always be, what's x with? How are they connected? And how do we undo that, right? And remember, the equals sign separates what x is with from just another separate room. So think of equals 9 as in a totally different space. So when I look at this problem, I think, okay, I've got x, it's with 3. They're connected by subtraction. There's the bell. They're connected by subtraction, which we undo by addition. So I'm going to add 3 once to each side. And when I say each side, I mean once on this side of the equal sign and once on the other side. So add 3 to both sides, and we do this because when we get 9 plus 3, which is 12, that this together adds to 0, and we like zeros because zeros don't need to be written, which means the only thing on that other side is x, which is nice for us because now we've got our solution. So you're thinking, okay, what's x with? How are they connected and how do we undo it? And look how simple that was. It took one step to do because there was only one thing with x. So when I look at the next problem, I think to myself, same thing. What's x with? 2. They're connected by division, which I undo by multiplication. So I'm going to multiply both sides by 2. Division undoes multiplication, so I'm just going to be left with x because these two, remember 2 divided by 2 is 1, I don't need to write that. Negative 4 times 2 is negative 8, and again, x is all by itself. And again, a simple one-step thing. What's x with, how are they connected, and how do we undo it? So if we look at the next problem, all right, now there's more stuff with x, right? So there's x. What's x with? It's hanging out with 2 and with 4. And so remember we talked about yesterday, we undo things in reverse PEMDAS order. So what I want you to think about is farthest thing away from x first. So whatever is the farthest, right? Like 2 and x are attached to each other. So those are gonna be like hard to separate. But that's because it's multiplication and division. We always want to do kind of like an outside-inside process. What's farthest away from x first? So when I see this problem and I think, all right, what's x with? 2 and 4. The 4 is farther from x, so it's going to be easier to undo. So undo that addition of a plus 4 with subtraction, once to each side to keep things balanced. 10 minus 4 is 6. 4, there it is. 4 minus 4 is nothing, which we like because nothing doesn't need to be written. So if these together produce a 0, then I'm just left with 2x on the other side because we don't need to write that 0. And now what we have is almost exactly the same problem as this here. This was a fraction, that's division. This is still one step. What's x with? 2. How are they connected? Multiplication, which we undo by division. So divide both sides by 2. And again, here's our solution. So the nice thing is we always want to try to make the unfamiliar problems be familiar. So if you notice, basically the problems are the exact same. Whatever x is with, we just undo it using the opposite of the operation that we're given. So if I've got subtraction, we undo with addition. If I've got division, we undo with multiplication. And here we've got more things, but we undo it the same way. Addition undoes, or subtraction undoes addition. Then we get to this easy problem where x is just by itself with 2. Divide it out, and you're done. So all of those problems are going to look the same here. And I know you're thinking it doesn't look the same, and you're right, they don't look the same, but they will be the same, I promise. All right, so those were our mild problems. Hopefully that's a quick little review from yesterday or from equation solving that you've seen before. So now let's move on to our medium problems, and I'll slow down just a little bit here because I know I went through that fast. When you're looking at these problems, and I'm going to erase that. I don't like that A there, it's in my way, so I'm just going to erase it. Okay, now it looks a little cleaner. Okay, so I see this problem and I think, okay, this looks familiar to me. in a way that I've seen this before. And we did that in the perimeter problem yesterday. And we've done that all the way since Unit 1. When we see numbers out in front, we know we just want to multiply them through. So even though this problem looks nothing like these, I'm going to try to make it look a little similar. So when I see that number in front, I'm going to multiply that through. So 5 groups of 2x's, 5 times 2, will give me 10x's. And 5 times -1, because remember, that's a -1 there, is a -5. And there's nothing to do with that equals 15, so I'm just going to bring it down. And now if you notice, this problem looks exactly like this problem with different numbers. So I ask myself, okay, I did that. I lost the problem. Here we go. Okay, I did that multiplication through, and I got to this new problem. So let's just worry about this. Like, that's what I want to focus on. All right, what's x with? This and this. What do we want to undo first? The 10 or the -5? Hopefully you're thinking that -5. So even though x is with 10, it's also attached to this with that minus sign, right? So we undo a subtraction with addition. So I'm going to add 5 to both sides. 15 plus 5 is easy. -5 and 5 together make a 0, so I don't have to write 0, so I just have to write the thing that's still there, which is 10x. What's x with? 10. How are they connected? Multiplication, which we undo by division, and so 20 divided by 10 is 2, and ta-da, we're done. So look at how simple that problem was. Even though it didn't look simple, we made it simple by getting rid of parentheses. So when there's a lot going on, we try to make it simpler looking, right? And then it's going to look like your mild problems. Even this problem went from having 2 things to just 1. Notice all of our problems are going to look smaller and smaller and smaller, like they're working their way down into one specific answer, right? So let's move on to this one. Oh my gosh, there's like a lot going on there, right? So I'm thinking, okay, how do I make my problem look simpler? Well, when I see this first, right, like there's a lot of things going on. Remember I told you yesterday, like it's kind of like cleaning your room. There's stuff all over the place. Like there's this and this and this. If your room had everything everywhere, your mom's going to come in and be like, you got to clean your room. There's too much stuff everywhere. There's X's everywhere, right? That's what she would say. So when I look at this problem, I think, all right, what is combinable together? Like what can I push together? So the first thing that jumps out at me is that I have 6 x's here and I have 5 x's here. So if I have x's all over the place, how can I get x by itself if x's are everywhere? I can't. So I have to group the things that are together, right? Like I have to push them so that they're not all over the place. So if I have 6 x's and 5 x's, what I really have there is 11 x's. And if I did that with the x's, I might as well do that with the numbers too. So you want to just pay careful attention here. This is a -8 and a +2. So imagine if these weren't there, and it's okay to put your finger on these, it's okay to like cross stuff out. I already figured out the x's, so I might as well just like scratch them out. That literally says -8 + 2. Brain, calculator, Desmos, whatever you want, -8 + 2 together is -6. And even if you don't trust me, I hope this works. Okay, I have color by number and YouTube up. My kids must have been on here. I hope this still records. What did I say? -8 + 2? -8 + 2. See, -6 if you didn't believe me. I didn't do anything to that equals 27, so I just bring it down. And again, it looks the exact same as this problem that we just did. What's x with? How are they connected? How do we undo it? The first thing we want to undo is the thing that's farthest away from x, and I don't mean this because that's in a totally different environment. We don't include that. The x is with a -6, which we undo with a +6 to make a 0. 27 + 6, 28, 29, 30, 31, 32, 33. -6 and 6 together make a 0. Zeros don't need to be written, so I bring down the 11x. 11 and x are connected with a secret multiplication symbol, though, even though it's not visible there. So we undo multiplication with division, and x is 3. So notice every time we do a problem, even if it gets crazy, what we're doing is we're making steps simpler and simpler and simpler so that eventually there's nothing left except for x. Okay, take a second. Jot down anything that you might think is important. I'll give you like 30 seconds. I'm drinking coffee. Good job, me. 30 seconds. Okay, that was it. All right. Last problem, and then you're going to get to try one on your own. Remember, make the unfamiliar be familiar, and try to make things simple by thinking about what's X with, how are they connected, and how do we undo it. I'm going to say that like a billion times in this unit. So now let's take a look at our spicy level. Okay. You might be thinking, all right, why does that look spicy? There's no parentheses in here like this one. There's nothing like all over the place like in B. So the reason I categorize this as spicy is if this were like this, we'd be looking at a mild problem. It's like what we just did in B and A here for medium, and it's exactly like this problem except different numbers, right? But the fact that that's there makes it a little bit challenging because you can't get X by itself if X's are all over the place. Kind of like what I said here. If X's are all over the place, we need to get them together. Now, an example that we just did, notice the X's were in the same room. So it was really easy to clean up by pushing them together, right? Like 6 X's with 5 X's makes 11 X's. That was pretty standard, right? What makes this problem different is that the X's are in different rooms. So I really want to combine this and this. And you might be thinking, okay, that's 9 X's. And I could see why you think that. The problem is that the X's are in different spots, so I can't clean up my room by going to your room, right? Like, this is my room, this is your room. How can I clean up my room by using that, right? Like, if you've got my stuff in your room, I got to get stuff from your room back to my room, right? So here's how we're gonna do this. When I see X's all over the place, my gut instinct is to put them together, just the same way that I did here. I put the X's together. Same thing here. I wanna get my X's together, but you've gotta be saying to yourself, where are they? And if X's are in different sides of the equal sign, we need different signs. So what I mean by that is, I'm gonna bring this 3X. I really wish this 3X were over here. So I can do that, I can move it, but I can't just like move it randomly, right? Like I've got to get it to disappear and reappear. So what I'm saying to you is this 3X needs to be over here, but in order to do that, I have to make it disappear. So how do I make this 3X disappear from that side? I've got to subtract it. So I'm literally going to take away 3X's from this side, and then I'm gonna take away 3X's from this side, from the other side, because again, I need to do once to each side to keep it balanced, see? But it doesn't make sense to put that minus 3X like underneath here, so I'm just gonna put it underneath its buddy over here. So notice now I have one negative 3X on this side and one negative 3X on this side, still balanced. And why I did that was because if I have 3X's and I take 3X's away, then this X disappears from that side, which is exactly what I wanted. So all I have left over there is a 5. And now what I have on the other side is 6X's, take away 3X's. So if I take away 3X's from 6X, I've got 3X, and now I've got that plus 10. So look just what happened, right? We had X's in different locations, so I needed to bring them together. But I can't bring them together unless I make them disappear from one side. And so to do that, I have to do the opposite of what I'm given. If I want this 3X to leave this room and go here, I need to take it away and undo it from this side. And what I do to one side, I do to the other. So that's why there's a minus 3X here, because I had to write a minus 3X here. And why did I have to write a minus 3X here? Because I was taking it away from this side to put over here. And then when I do that, I'm left with the same equation I've been doing the whole time, right? What's X with? How are they connected? How do we undo it? I'm going to undo that addition by subtracting. 5 minus 10 is negative 5. What's x with? 3. How are they connected? Multiplication, which we undo by division, and it's okay to leave your answer as a fraction, negative 5 over 3. Fractions are friends. So again, it looks a little weird because you're like, wait, how come we didn't add them? We didn't add them because they weren't on the same side of the equal sign. When x's are on the same side of the equal sign, the way they were here, there's nothing to do. Same side, same sign. There's no messing around. Like you just take whatever you have here and here and you just put them together. But if the x's are on different sides, your first step is going to have to be to undo one of the x's and move it to the other side. And you can't move unless you make things disappear. So they have to disappear from one side to the other. So different sides, different signs. Same side, same side. You keep everything the same here. I didn't change anything here, right? Like there's a positive here. Here I went from positive to negative because they were on different sides and I had to undo. Okay, I hope that makes sense. Try to give it a go on this problem. Think about what are my first steps? What can I do to make this look simpler? And kind of go from there. All right, and if not, that's what practice is for, and we've got tomorrow. I'm sorry the video was super long, and if you have any questions, I'm sure the lovely math teachers would be able to help you out. All right, good luck, and do that last problem on your own, and put the answer in formative. Thanks so much. See you tomorrow.